All right, iChem lesson 19 on basic stoichiometry, our first one in the Unit 6. We're going to be combining the Unit 5 stuff, the unit conversions, with the older stuff, the reactions that we just spent the past couple of days reviewing. So starting from a balanced equation, so that balancing becomes really important, we can actually create another jumping off point between our two mole maps, essentially. What's called a mole ratio. So if we can do all sorts of conversions we had done before on hydrogen gas, from mass to moles, or from particles to moles, or moles to particles, whatever. We can do that for oxygen separate, but now we're going to talk about it in the context of a chemical reaction. So converting between moles of each of them using what's called a mole ratio. So a mole ratio is essentially the coefficients in the balanced equation representing the number of moles. They're equality statements that compare the number of moles of one compound to a number of moles of another compound in the same balanced equation. So the equation has to be balanced, and both things that you're talking about, both compounds, have to be in the same reaction. So for this particular reaction, if we look up at the balanced equation, 2 moles of hydrogen is the same, or equals 1 mole of oxygen in our ratio here. 2 moles of hydrogen, 1 mole of oxygen in the reaction. Another way of saying this is for every 2 moles of hydrogen that react, 1 mole of oxygen also reacts. Just another conversion factor. So on Monday we'll make another card to go with this one. If you can think ahead and want to make your card right now, you're welcome to. So let's do an example first before I give you some steps. So same reaction equation, and we want to know if hydrogen gas and oxygen gas react according to the equation above, how many moles of oxygen are needed to react completely with 0.64 moles of hydrogen. So this is a simple mole to mole stoichiometry problem. 1 mole of hydrogen, not 1 mole of hydrogen, so moles of hydrogen to moles of oxygen. So we're starting with our given as always, 0.64 moles of hydrogen. Before I do anything, I'm going to take moles of hydrogen, the whole unit, the unit and the of what, and put it on the bottom right so that those will cancel. I want moles of oxygen, so I'm going to put that on top. This is a mole ratio. Once I have this written, moles of what, I come to my balanced equation and fill it in with the coefficients. So in front of the hydrogen, or in front of the oxygen rather, there's nothing, so it's a 1. In front of the hydrogen, there's a 2, so I plug in a 2 down here. That's a mole ratio. 1 mole of oxygen for every 2 moles of hydrogen. The moles of hydrogen cancel out, and I'm left with moles of oxygen. Plugging my calculator, I just do 0.64 divided by 2, gives me 0.2 moles of oxygen. So let's review the steps that I just went through. Step 1 was to start with a balanced equation. Sometimes you'll be given an equation that's already balanced. Sometimes you're going to have to balance it yourself, or write it yourself from a word equation, predict the products, and so on. All that good stuff. Step 2, write the given. We always, in the top left corner, write the given. Step 3 is to identify your unknown. And we're going to start doing this with writing the given in the left corner and the unknown in the top right corner to give us some guidance. What am I trying to find? So, and then step 4 is, once you have the whole dimensional analysis, set up the dimensional analysis that starts with that given, and then plug it into your calculator, carrying through the units the whole time. So let's look at this other equation. Here's a reaction equation on the top. Sodium hydroxide reacts with carbon dioxide to form sodium carbonate and liquid water. This actually isn't one of our regular reaction types. This is a base reaction we'll talk more about in a later unit, but we're starting with the equation. The first step, and step number, is to start with a balanced equation, so we need to balance this equation. I have 1 sodium. Over here I have 2 sodium, so I'm going to put a 2. Now I have 2 hydroxides. Well, I actually have to count oxygens, hydrogens, and everything separately here. So I have 2 hydrogens. I have 2 hydrogens over here. I have 1 carbon and 1 carbon, and I have 1 plus 2, which is, no, not 1, sorry, 2 plus 2, which is 4 oxygens, and I have 4 oxygens over here. Now it is balanced. Step number 2 is identify your given in the problem. So the question is calculate the number of grams of carbon dioxide that can be absorbed by a complete reaction with sodium that contains 5 grams of sodium hydroxide. So 5 grams of sodium hydroxide is my given. Third step, identify your unknown, what you're trying to find in the problem. Grams of carbon dioxide. We have a set of conversions that have to do with sodium hydroxide, which is our previous kind of Unit 5 stuff. We can do the same type of conversions on carbon dioxide, and what combines them is that mole ratio. So I'm going to start my dimensional analysis with my given in the top left corner. Immediately I'm going to take the whole, everything but the number, the unit and the of what, and put it in the bottom right. Before I can use my mole ratio to get between sodium hydroxide and carbon dioxide, I need moles. So I'm going to go to moles of sodium hydroxide. I have to keep going. Well, I guess plug in the numbers first. So to find the molar mass of sodium hydroxide, I have 1 sodium, 1 oxygen, 1 hydrogen. Roughly molar mass of sodium is 23, oxygen 16, and hydrogen is 1. I add it all up and I get 40 grams per mole. So take this 40 grams per mole and I plug it down here. 40 grams and 1 mole, my conversion factor. So now immediately take the moles of sodium hydroxide, that goes in the bottom right corner. Now that I have moles of sodium hydroxide, I can go across the bridge, mole ratio, to get moles of carbon dioxide. From a mole ratio, the numbers, when I have moles to moles, is the only time it's possible for you to have a non-1 in front of the mole. Notice always in the other conversions it's 1 with mole, but if I have moles over moles, then I come to the balanced equation and I look for carbon dioxide, the coefficient, for sodium hydroxide, sorry, the coefficient is a 2, so I put a 2 down here. For carbon dioxide, the coefficient is a 1, so I put a 1 down here. All right, now keep going. Because I'm asked for grams of carbon dioxide, I'm not done yet. So moles of sodium hydroxide are gone. I'm left with moles of carbon dioxide. Immediately put that unit on the bottom. And I'm looking for grams of carbon dioxide. Fill this in with your unit conversion. First I have to find the molar mass of carbon dioxide. 1 carbon, 2 oxygens. The molar mass of carbon is 12, oxygen 16. Add it all up, I get 44 grams per mole. 44 goes with the grams and the 1 goes with the mole. Notice the only place I have something other than a 1 with moles is in the mole ratio when I have mole to mole. Just as in the previous unit, with moles in your molar mass, it's always a 1. And I plug it all in, 5 divided by 40 divided by 2 times 44, I get 2.75 grams of carbon dioxide. Don't forget, make sure you take all of your notes, record all of the examples, because the Google form will ask you questions about these examples in particular.